So today I'm going to be talking about custom runtimes on AWS Lambda. I'm also giving a talk later, and this one's just a quick lightning talk. The talk later is about Lambda security, but this talk is about custom runtimes on AWS Lambda. My name's Ben, and I work for a tech startup in London called Theodo, which helps startups launch digital products and larger companies deliver more at a startup speed. We're about 80% engineers, and we have offices in London, Paris, and New York. This talk is going to focus on AWS Lambda. It's a 15-minute talk with about 20 minutes of content, so I'm going to go through quite quickly. If you just raise your hand if you've used Lambda before. Awesome, so I can go through quite quickly. So with Lambda, it's a functions as a service from AWS, and it has a number of different supported runtimes. So runtimes are the language that you run on Lambda. The supported ones are Python, .NET, Java, Ruby, Go, and Node.js. At Theodo, we're finding Node.js to be one of the most effective on Lambda because TypeScript allows really good type sharing between front-end and back-end code, and it allows to really empower developers who may be more on the front end to pick up back-end technologies. I recently had a client, though, who had a very particular need. He needed to run PHP on Lambda, which obviously sounds fun. Now, just to be clear, this is not my choice. PHP runs a great part of the internet, and it's good for what it's good for. I wouldn't necessarily use it on Lambda, but these steps are universal in how you'd run any custom runtime on AWS Lambda. So the problem with this project was the client wanted to use PHP. They had an existing code base. They had existing engineers who didn't want to move from PHP. But AWS didn't support PHP, and still doesn't, actually. This is a broken slide. But anyway, that was a tweet from AWS at the Innovation Summit last year, where they announced Lambda Layers and the custom Runtime API, which allows us to run PHP as a custom runtime. Now, previously, to run a custom runtime, you'd have to use Node.js, and it was a bit of a hack. But with Lambda Layers and the custom Runtime API, it's really clean, and we're going to go through the steps of how to achieve that. I think I've jumped too many slides. There we go. So what is the Runtime API? Well, the Runtime API is an HTTP interface that connects your custom runtime with the AWS infrastructure. Now, it's a bit weird that it's an HTTP, but it's intentional. If it was an SDK, it would have to support different languages, which would defy the whole point. So by being an HTTP, your language can make calls to AWS, which can then return the next invocation or allow you to post responses back to the user. Now, the custom runtime API has 4 routes: next invocation, invoke response, invoke error, and initialization error. The get next response is a get request, as you might imagine, which just returns a JSON payload of whatever request came in and headers with metadata like request ID or X-ray logs. So you can invoke this really cleanly just with a curl request, and you just call runtime/invocation/next. If you want to send back a response, imagining a user's made a request on a website, it's gone through API gateway and hit Lambda. You've called getNextRequest, you've got the body of that. You've called your handler function, the piece of code that's going to run your business logic. Then you want to send the response back. You just call the post to invocation/the request ID, which comes through in a header from the getNextRequest from AWS, and then that will send back to the user. And for errors, it's exactly the same. It will log in CloudWatch and come back as an error to the user, and initialization errors work much the same. So what is a runtime? Well, a runtime is a program in terms of serverless, or in terms of Lambda, that runs a Lambda's handler function when a method is invoked. A custom runtime could be a shell script. It could be a script in something supporting the underlying operating system of Amazon Linux, or it can involve a binary that's compiled on the Amazon Linux operating system. When you have a custom runtime, you need a Bootstrap file. That's basically what connects the custom runtime to AWS's infrastructure. This will do the setup. It will get the handler function name from an environment variable. It will pull that API we saw for the next invocation. Now, this seems a bit weird, but it sort of ties into the whole idea of warm Lambda invocations. When you have a custom runtime, the Bootstrap file is basically doing a while true loop and iterating over, keeps calling, keeps basically polling getNextRequest. And when a request comes in, it's called. When a request comes in, it gets a response. Now, AWS will shut down your function if it's not invoked, fairly frequently, and that's the idea of cold starts. But we are going to be doing a loop here, while true, inside the Bootstrap file. Now, a really simple example, and I agreed not to have my laptop, but I realized I can't scroll, which is going to be a problem. But basically, this is a shell script where, well, further down, there's a call to getNextRequest inside of a while true loop. It calls a handler function, also in bash, and then it does a post back to send response. So in a simple example, we have a Bootstrap file which does the linking from AWS to the Lambda function, and then your handler function is normal, but here we can see it's a shell script. in Bash, which you wouldn't normally see on AWS Lambda. So if you have a custom runtime, we have the idea of a Bootstrap file and a handler function. And if you're doing a custom runtime with a binary, so you're doing something not supporting the underlying operating system, you'll have to include that binary with the Bootstrap file, which obviously makes a Bootstrap file quite big. This becomes a problem when you have many Lambda functions all with their own Bootstrap file. We have a large dependency that's using up our code storage, which does have a limit, and also making our deployment slower. Luckily, this is where the second part of the AWS announcement at the end of last year comes in. Lambda layers are a great way to share data, to share code, or to share custom runtimes implicitly across your Lambda functions. With a Lambda layer, we can change that previous approach to have one dependency here, a binary, with our Bootstrap file, shared across multiple different Lambda functions with their own handler functions. This makes our deployments cleaner. It reduces the amount of code we're sending to AWS, which first of all makes developers happy because they don't have such of a latency when they want to deploy, and it also reduces how much of that code storage limit we're using. On the interface of AWS, if you're creating a Lambda function, to create a layer, it's quite simple. You just click layers, and then you can click add layer and upload a binary. Obviously, we all love infrastructure as code, and the serverless frameworks are a really nice way to handle layers. So you can simply say layers, a path in your local directory to layers/runtime, which would be a directory with your binary and your Bootstrap file. And then our function here, we say our handler function, which could be written in any language we want. Here it's PHP, and then we're referencing that PHP layer. How do we have that binary of PHP? Well, there's a few steps we have to go through. Obviously, we can't just compile it locally because most of us aren't running Amazon Linux as our local dev environment. So we need to find the AMI of the right Amazon Linux operating system, which you can do with that regex or look up in the documentation. We can then spin up a large EC2 instance if you don't want to wait around for the compilation time, download the source code for the language you want, and follow the steps to compile. You then SCP that down locally, add execution permissions, and then we can zip that with a Bootstrap file that calls in a while true loop that getNext request, and then gets the handler function and sends a response back. And that's our Lambda layer. That'll link in then to the infrastructure as code we saw a second ago. So we'll just reference that directory, and actually serverless, the framework, can do the zipping for you. Sorry, that's the zipping of both the binary file and the handler file. We were going to see an example of the PHP custom runtime here. And actually, I don't suppose, could we scroll down on the, hi, sorry. Would you be able to scroll through this quite slowly? Sorry about this. So this is PHP. We see we've got shebang opt/bin/PHP. We have a getNext request function, which is calling basically through Guzzle, the PHP HTTP clients, a send response, which is doing a post to that method we saw before. And if we go a little bit further down, we'll see a do while true loop where we get next request. We'll call the handler function, and if we go a little bit further down, we'll do a post to send that response back. Thanks so much. That's a PHP example of a custom runtime. So we just compiled a PHP binary, we wrote this Bootstrap file, and then we deployed it through the serverless framework, and we're good to go. Now, this has also not worked as an embedding, but any of you who've tried to do PHP on Lambda, and I doubt there's that many of you, but if you are trying to do it, the Bref, which is French for brief or fast, framework is a really good way to do it. You might ask why we didn't use it, because it applies documentation, it has the PHP runtimes ready, and it has integrations with classic PHP frameworks like Symfony. Unfortunately, they were doing the same work we were doing in the same couple of weeks. So the announcement came out, and their pull request to support custom runtimes came out about the same time we finished with our clients, and the flexibility we had in maintaining our own custom runtime meant we stayed doing it that way. But if you were specifically doing PHP on Lambda, definitely check out the Bref project. But any custom runtimes can follow the same set of steps we've seen. What is the problem with doing a custom runtime in AWS? Well, there's more complex local developments. Basically, you have to write a local Bootstrap version of that previous file, spin up a web server, and sort of mock API gateway a bit. Managing Lambda layer versions can get confusing. If you share one across your whole stack, a developer, if they're upgrading one Lambda function, could break other ones in production. Updating the underlying language for security patches is a bit painful. We actually have that done completely on a CI platform now. And finally, you get some operating system concerns. So OpenSSL, for example, in a recent PHP upgrade, had quite a painful problem that we had to fix, which sort of takes away the serverless part of serverless. So really, if you can use a standard runtime, do use it. But if you have a specific use, maybe you have a code base that you want to reuse some of, or a team that can't move from a language, it is completely possible, and AWS is quite flexible. The custom runtime API allows you to create these. Lambda layers are a great way to share large dependencies, be them custom runtime, be them libraries, be them data maybe for a machine learning model. Lambda layers are a really efficient way to share these dependencies. And they also reduce our deployment size, which makes deployments much faster. AWS is a very flexible tool, so you can do whatever you want in any language you want, but I'd recommend staying to the natively supported languages as much as possible. Just before I wrap up here for questions, I'm doing a few different parts of advocacy around serverless through Theodore at the moment. So I have a serverless transformation blog on Medium with similar articles to this and some around security in AWS Lambda. Feel free to follow that, and if you are interested in being featured, maybe if you have a serverless architecture, get in touch with me on Twitter. We also have a newsletter that goes out every week with the top 5 serverless articles of the week, putting them into context and giving some of the implications of the announcements. And finally, we also have a podcast now, which is an audio version of that newsletter with a bit more context and implications and some interviews with industry-leading experts. One last thing. We open sourced a project around serverless last week. So LessDevTools is a command line dashboard interface for managing your serverless applications. It's not a replacement for anything like Thunder, Lumigo, or Espagon. It's really a dev tool for when you're developing your Lambda function. If you don't want to jump to the AWS console every 5 minutes to figure out what's going on, it gives you instant metrics of your stack with quite a nice overview, and it's in the terminal, so it's quite cool. That's everything I had to say about custom runtimes. If you have any questions, I think we've got a few minutes now. I'll be around for the rest of the day, and if you want to reach out to me on Twitter, feel free. One of those QR codes goes to the blog, one of them goes to the newsletter. I don't remember which one's which, so maybe subscribe to both. And yeah, if you have any questions.
Anyone, any questions? Everybody want food? Oh, one here.
When using custom runtimes, did you notice particularly with PHP, what did you find the speed to be like of each invocation?
We found the speed to be okay. We've not properly contrasted it with a natively supported language. It's on the roadmap for us to do, but the users are okay with it. From an engineering point of view, it's going to be a bit more inefficient.
Okay. Thank you.
Cool. Any others, or I think we're good. Thanks.